What are ephemeral resources in Terraform? Let's find out. What's up, everybody? It's Ned Bellavance, nedinthecloud.com, and welcome to another Terraform Tuesday. Today, we're going to be talking about a new resource type that's in Terraform 1.10 that is ephemeral resources. We'll get into what they are, how you can use them, and what are some future plans for ephemeral resources. Terraform 1.10 has introduced the concept of ephemeral resources, outputs, and variables to Terraform. Before I dig into the details of how they work, first, I think it's important to understand the problem that ephemerals are trying to solve. We all know that Terraform state can contain sensitive information. I mean, after all, it contains all the attributes of each resource and data source and any output values that are defined in your config. Terraform uses these values to calculate an execution plan when updates are made to the configuration. So that information kind of has to be in state data. An additional concern is sensitive information that is found in saved Terraform plan files. Your plan files not only contain the entirety of the configuration, but also the planned changes and the variable values that were used to create the plan. How do you remove sensitive information from state data and from saved plans? That is what ephemeral resources are meant to do. Unlike data sources or managed resources, an ephemeral resource and its attributes are never written to state or an execution plan. Additionally, ephemeral resources and their properties cannot be used in the context of a non-ephemeral object. I mean, after all, if they could, then the values of ephemeral resources would end up in state data or a plan, and that would defeat the entire purpose behind them. That does place some heavy restrictions on how you can use ephemeral resources today. Given that you can't use them inside of a managed resource or a data source, what good are they? Well, the primary use case seems to be provider authentication, and in fact, that's the first time I encountered ephemeral values. If you go back and watch my HCP Terraform stacks video, or just take a look at the code, let's jump over to a browser and do that, I declare a stack variable called an identity token. And inside of that variable declaration, ephemeral is set to true. We are now creating an ephemeral input variable. This token is used to authenticate to Azure through OIDC. It's meant to be used a single time and doesn't need to persist anywhere. The next time you run a plan or an apply, a new token will be generated for that run. The provider configuration for the stack uses the identity token value for the OIDC token argument down in the Azure RM provider block. The value for the identity token comes from a special block type that is specific to Terraform stacks called identity token. And identity token takes a label of Azure RM to indicate that this token is intended for an Azure RM provider target. And inside of there, it specifies the audience. This block type predates the release of Terraform 1.10. And I think there's a chance it might be replaced with an ephemeral resource instead. So let's take a look at the syntax of ephemeral resources and some examples to better understand the syntax and the restrictions on ephemeral resources. The syntax for an ephemeral resource is basically the same as a managed resource. Starts with the keyword ephemeral, and then the ephemeral resource type, and then a name label, and then inside the block you have a set of identifiers and expressions that form the arguments for the block. It's basically the same as a managed resource in terms of its syntax. However, you can't use a provider's managed resource types as ephemeral resources. Instead, ephemeral resources are a separate category in the provider documentation, and they require a different implementation in the plugin. Currently, the Azure RM, AWS, and GCP providers have all added support for ephemeral resources, with more coming in the future. The Azure RM provider supports 2 ephemeral resource types in version 4.11 of the provider. the Azure RM Key Vault secret, and the Azure RM Key Vault certificate. And those make a lot of sense when you think about it. Where do you most worry about sensitive values? Well, it's probably values that are coming from Key Vault. Let's take a look at an example of how we would have used Key Vault secrets before. Over in Visual Studio Code, in my Terraform Tuesday repository, I have a new folder that's for ephemeral resources. And in there, I have already set up a Key Vault that has two objects in it. One is a secret and the other one is a certificate. Now, how would we typically access this information? Let's take a look at the data source example that I have here. Inside the main.tf, I have two data source blocks. The first one grabs the Key Vault secret, and the second one grabs the Key Vault certificate. I'm going to pull up the terminal, and I've already applied this example. I'm going to query Terraform state for what objects are currently stored in state. So I'll do Terraform state list, and that pulls back two data sources that are stored in state, and that's the Key Vault certificate and the Key Vault secret. If I do a Terraform state show for the Key Vault secret, it will return back to me the contents of that Key Vault secret, including the actual value. Now, it's stored as a sensitive value, so it won't show it to me directly, but that value is stored unencrypted inside the state. If we do a Terraform state pull, which pulls the entire contents of the state data, scrolling up through the state, there is the value of our Key Vault secret in plain text stored in our state. Now, that's no bueno. We don't want our Key Vault secrets to be stored in plain text in our state data if we can help it. Let's see what happens when I add ephemeral blocks to the configuration. Okay, I've updated the configuration to have ephemeral blocks instead of a data source block. And I'm going to add a new output value here just so that there's something for Terraform to apply. I'll pull up the terminal again and I'll run a Terraform apply auto approve to automatically apply this updated configuration. And now if we jump ahead to when the apply is complete, let's take a look at what's in the state data now. My Terraform state now shows the metadata about the state and the single output that's defined, and no resources at all. So the ephemeral resources that we added to the configuration are not being logged in state at all. We can also run Terraform state list to confirm that there are no data sources or resources in our configuration anymore, and there aren't. Now you might be wondering, what can you do with this secret? Could you use it in a regular resource? The answer is no. Let's take a look at another example. In the folder ephemeral CG example, I'll open up the main.tf, and in here I'm retrieving the Key Vault secret and the Key Vault certificate using the ephemeral resource blocks. Below that, I'm creating an Azure resource group, and inside of that resource group, I'm creating an Azure container group. The one container that makes up this container group is being passed some secure environment variables, and one of those is the Key Vault secret, and I'm using the reference ephemeral.azuremkeyvaultsecret.example.value. Now, if I pull up the terminal and run a Terraform validate, I receive back an error invalid use of ephemeral value. Well, what does this mean? To generate a proper execution plan, Terraform would have to persist the secret value beyond the planning phase. Since we're trying to avoid storing that value in the planning phase or in the resource itself, Terraform throws an error. So if we can't use ephemeral values with managed resources or with data sources, where can we use them? You can use them with the following object types. You can use them in local values. The local value will inherit that ephemeral marker, so it won't be able to be used in non-ephemeral contexts. You can use them in provider blocks. You could use them to configure the credentials of a provider, and we'll see an example of that in a little bit. You can use them with other ephemeral resources. You can reference the attribute of one ephemeral resource in another, since neither of them persist. You can use them with ephemeral variables. You can pass an ephemeral value to a child module if the input variable inside that child module is marked as ephemeral. You can also use them in outputs. You can pass an ephemeral value to a parent module if the output is marked as ephemeral. And lastly, you can use them in provisioner and connection blocks. Note that ephemeral outputs cannot be used in the root module because then they would be written to state, which defeats the whole purpose of ephemeral values. Also, since ephemeral values are not written to the plan file, they are calculated on every Terraform run. So you might end up getting a different value for plan than you do for apply when you're using ephemeral values if they change. Honestly, the biggest use case at the moment is for provider configuration. Say, for instance, you are using the Kubernetes provider to deploy a manifest, and you have the Kubernetes credentials stored in an Azure Key Vault secret. In fact, we don't have to suppose that. I have that set up in the demo. Over in Visual Studio Code, again, I have two AKS folders. AKS setup will deploy a very basic AKS cluster, and it's going to store the credentials for that cluster in Key Vault. If we take a look at the main.tf for this, it creates a resource group and a Key Vault, and then it uses the module for AKS to create a very basic AKS cluster. Once that cluster is created, it creates 4 secrets in Key Vault. The first is the raw kube config, and below that, it also stores the client certificate, the client key, and the cluster CA certificate. These are all now stored in Key Vault, and I can make use of them through ephemeral resources. That's what's going on in the AKS example directory. Inside of there, in my main.tf, I have an ephemeral block here for the Key Vault secret. And I'm using a for each loop to grab the client certificate, the client key, and the cluster CA certificate. So yes, ephemeral resources do support meta arguments, and I'll talk more about that in a moment. I'll grab each of those secrets, and then down in the provider block for Kubernetes, let me hide the files so we can see the entire value here. I have the client certificate, client key, and the cluster CA certificate, each being sourced from the ephemeral Key Vault resource. Just below that, I am then creating a namespace in the Kubernetes cluster using those credentials that are defined in the provider. Let's see this in action. I'm going to run Terraform apply, and let's take a look at what it's actually doing during the planning portion of the process for Terraform apply. Scrolling back up to the beginning, it's doing something interesting here. For each of the ephemeral Key Vault secrets, it goes through a process of opening each one and then closing it when it's done. That opening and closing process is essentially loading the value into memory and then flushing it back out of memory. So that value is never persisted to storage anywhere. Once it's successfully built its plan, all of that information has been flushed out of memory. Now let's approve the plan, and it will move to the apply phase, and we'll see that it does something very similar during the apply phase. Once again, it goes through that same process of opening each of the ephemeral resources and then executing on the creation of that Kubernetes namespace. Once that creation is complete and it's done with using that provider, it closes each of those ephemeral resources, thereby flushing it from memory. If the values inside the Key Vault had changed between the plan and apply phases, it would have fetched the newest values from Key Vault as part of the apply. Because the provider configuration is never stored in state or plan, this is a great use for ephemeral resources. As you already saw, we can also use meta arguments with the ephemeral resource. You saw that we could use for each. You can also use depends on, count, provider, and lifecycle blocks. The other big use case is probably for provisioners. But here, I would remind you that provisioners are considered an anti-pattern and not recommended. If you must, though, you could do something like run remote exec every time a member is added to a cluster, like this example code here. In this configuration, let's assume that I'm creating Azure Linux virtual machines using a for each or a count loop. Every time the list of IDs in that loop changes, I want to do something to bootstrap or update the cluster, and I'm using the Terraform data resource to do that. We also have an ephemeral block here that is retrieving a Key Vault secret that could be the credentials to use to connect to one of the nodes in the cluster. So in the connection block, I'm retrieving the private key that's stored in the ephemeral resource and using it to connect to one of the nodes in the cluster, and then running some sort of remote exec process on that node in the cluster. Now, this is not a full-blown example. I didn't actually write the whole thing out, but this is a valid use for ephemeral resources if you need to use provisioners. What about managed resources? Ephemeral resources are meant to keep sensitive information out of state and out of plan, but only for specific use cases. As we saw, if you try and use an ephemeral marked value in a resource, it's going to throw an error, and the same thing will happen if you try to use it in a data source or a root module output. You'll get the same error. So what about all of those sensitive attributes that might be in a managed resource or a data source? How do I use a Key Vault secret in a container group and not have it persist in state? Today, you don't have that in native Terraform. What you could do, and what I'd recommend, is assign that container group an identity, grant that identity access to the Key Vault in question, and mount the secret as a container volume. Then Terraform isn't really involved except for passing along the Key Vault ID. But if you did want to pass that secret value directly, you would use a data source, and as we saw, that data source value is stored in state. That's why encrypting and securing your state is so important. There is some hope on the horizon. Longer term, work is being done to create what are called write-only attributes for resources. The value of these attributes is not stored in state, and the current value can only be overwritten. It cannot be read, thus making it write-only. Write-only attributes are very much in the experimental stage, and they will require that providers update their resources to support this concept, much in the same way that providers have to add support for ephemeral resources separately from managed resources. I don't know what the final shape of write-only attributes will look like, but you can dig through the linked pull request if you want to see the suggested code changes so far. I'll put that link down in the description. Ephemeral resources are the beginning of an answer for keeping sensitive data out of state in a systematic way. 1.10 introduces ephemeral resources, variables, and outputs. And right now, the big use cases are for provider configuration and provisioners. Further development will hopefully include write-only attributes and maybe more. I should also mention that ephemeral resources are currently in beta, and HashiCorp is actively looking for feedback. The functionality of ephemeral resources may change in future versions of Terraform, so I wouldn't start using them in production just yet. If you want to tinker around with ephemeral resources yourself, I have some code examples in my Terraform Tuesdays repository, as you saw. Remember, you'll need Terraform 1.10 to run them. So what do you think? Do ephemeral resources solve a challenge you're dealing with today? Do you have suggestions for improvements? Let me know down in the comments. That's going to do it for today. As always, thank you so much for watching. Please subscribe if you don't mind. Until next time, keep calm and Terraform on. You know, when it comes to tacos, they're all ephemeral because they disappear into my belly.